So now that we are 99.9% of the way done with our render, all we have to do now is tie up some little loose ends that'll take only a few minutes and then get the rendering set up and actually hit that render button to get our final result. First things first though, I actually want to go to just a random frame. I'll go to this frame right here because we get to see a nice pretty smoke plume as well. I'm going to come up to the render tab in the upper left here and select this button that says render image. Now basically what this does is it actually fully renders the image, in this case using Blender's Eevee real-time rendering engine, and you'll notice that this is the final render. But for some reason, our look dev, our viewport right here, looks a lot better than it. You know? So why is that? Well, first things first, we actually have lighting in our look dev mode. We're actually not in the final rendered view when we're sitting here in look dev mode. We're using basically a temporary lighting setup that Blender includes when we're using look dev to help us put materials together to help speed up the process so we don't have to set up lighting ourselves. But if we come into actual rendered view up here, well, we don't have that lighting. We have a very basic and boring scene with no lighting. So let's go ahead and get some lighting set up. Now, you could use lights, but in this case, lights wouldn't really make much sense. So I'm actually going to use environment lighting, which means we're going to use this world around us to light our scene. So in order to change the world settings, all we need to do is click on this world over here. And you can see we have a couple options here. We have the color, which we can change. So if we want it to be, greenish or brighter or darker, or even tweak the strength of it, we could do that. But in the end, you can only do so much with a solid color. Instead, I would much rather have some sort of environment texture that represents something that would light this accurately and well. And I've actually already put together a world file for you guys to use to put together in your scenes. And this is included in the Rocket Resources Blender file that we got the smoke particle material from earlier. So in order to import this, all we need to do is click File up here in the upper left, come to Append. You can see I'm actually already in another file, but what we need to do is open up our CGC low poly rocket folder, rocket resources.blend, open up the world folder and select the rocket environment world. And then we'll click append from library up here. Now in our world data block selector up here, all we need to do is select the new rocket environment world that we just imported. And just like that, you can see we have this really cool environment texture courtesy of HDRI Haven, who has a bunch of free and copyright free images that you can use on their website. Specifically environment textures. They are HDRI Haven after all, and you can see that now we have this really nice image. But this poses a problem. If we play this animation, you'll notice that the background flickers. This is because we are in orthographic view, which means we're basically sampling 1 pixel per frame. And it's sampling random pixels from around this area as we rotate. That just doesn't look good, right? We don't want this flickering effect. It just looks horrible. So in order to counter this, let's go ahead and add in a colored ground plane, just like we see in our final animation here, if we can get it to play. There we go. A colored ground plane, so we don't see this background, and we can make the color match our ground material really well here. So in order to add a ground plane, first things first is I'm going to make sure that my, what is this here? My 3D cursor is in the center of the world by pressing Shift S. Oops, Shift, no, oh my gosh, I am messing up like crazy. I had my hand in the wrong position on the keyboard. I'm gonna press Shift S and select cursor to world origin. Then all I'm going to do is press Shift A, and from the mesh menu, I'll select plane. And then all we have to do to transform our plane into a ground plane is make it really big. So I'm just gonna press S to scale it, and we'll scale it up so it is absolutely massive. Like huge, as far as you can see, huge. The goal is, if you're in camera view, you should not be able to see the edge of the ground plane. So now if I go ahead and move this down a little bit, just like that, so it's a fair distance below our whatever this is, our scene, I'll call that. We just want to make sure it's a good amount below, and then we can go ahead and add a material for our ground plane, but not before we name it ground plane, just like that. Perfect. So now I'm going to go ahead and click on the materials tab here, and I'm going to click plus to add a new material, and I'm just going to call this material ground plane. Actually, you know what? I have a much better way of doing this. I'm just going to rename this bad material because we don't want it, and it has a typo, whatever. Either way, I'm going to click this X right here, and I'm actually going to select our ground top material right here. That way, what we can do is we can create a duplicate material by clicking this 2, or we could also click these 2 pages right next to each other, which will create a duplicate as well. And I'm just going to name this material ground plane, just like that. And then I'm going to set the base color's value to 0.125. That way, it's just a darker version of the same color we have here. That way, we aren't wasting time trying to figure out what exactly certain elements are. So we just took this material on our planet surface here, duplicated it onto our ground plane, made it a single user copy, and then just darkened it up a little bit. And now if we go into our 3D viewport, we can see that that flickering is now gone because our world is hidden behind our ground plane here. So this is pretty great, and that ties up the rest of our loose ends, which means the only thing we have left to do is to actually render, to set up rendering and to actually render. So let's really quick just render this image to make sure that, in fact, we do have that lighting and we do have that ground plane, perfect. And in order to render, so far we've been rendering using Blender's real-time rendering engine called Eevee. And Eevee is great for a lot of things, especially for previewing our final render. But when we actually want to render, if we want a really high quality, very accurate, good-looking render, we actually want to use a different rendering engine, and that is Blender's Cycles rendering engine. And Cycles is a path tracing engine, which means that it actually physically simulates light. You see, Eevee is something more of what you'd find in like a video game, but Cycles is what they use for professional visual effects and stuff like that. Those path tracing engines are what they use for that. So we want to use this same high-quality rendering engine in our final result here. So in order to switch things over to use the Cycles rendering engine, all we need to do is come into our rendering tab right here. It just looks like the back of a DSLR camera. And we need to change our render engine from Eevee to Cycles. And note, if you are in rendered view, like I am right now, you'll see this mess of pixels, right? And actually right now, it's so computationally intensive that my screen recording is probably super choppy or frozen altogether. No worries, I'm not going to do anything big here. I am going to temporarily change this over to use a different piece of computer hardware though, so you guys can still see my mouse moving without any lag. But what I actually just did there was change Cycles over to use my GPUs in my computer instead of my CPUs. You see, by default, Blender uses, or actually specifically Cycles, uses your CPU, your central processing unit, to calculate things. But if your computer has a GPU, or graphics card, graphics processing unit, video card, those words are all synonymous, as long as it has one of those, you can actually render quite a bit faster. As you'll notice, now I can like scroll around the scene and I get a pretty noiseless image in a matter of seconds, in less than a second, as opposed to a matter of seconds. So I want to show you guys how to enable GPU rendering if you have a GPU, or maybe if you're not sure if you have a GPU in your system, you can find out here right now. So right now, this should be on CPU. I'm going to leave it on GPU compute though, again, because it lags my screen recorder. I'm going to come up to Edit and select Preferences. Now in my System tab, you'll notice that by default, this should actually be like this. It should say none right here up by the Cycles render devices. We have none, we have CUDA, and we have OpenCL. Now, if your computer has no GPU, we're just gonna leave this set to none. If your computer has an NVIDIA GPU, we're gonna select CUDA and then check the boxes next to both of your graphics cards, or however, not both of yours, because most people don't have more than one, but I have two. So I'm gonna place a check mark next to both of my graphics cards, but not next to my CPU. And if you have an AMD graphics card or another graphics card, you're gonna select OpenCL, and you should see those here, and you can place a check mark by those. But as you can see, it says no compatible GPUs found here because I don't use AMD cards, I use NVIDIA cards, so I have those right here. Now, if both of yours say no compatible GPUs found and you're not sure whether your system has a GPU, odds are you don't have a GPU. It's a bummer, but just go ahead and select none. It just means that the process of rendering is going to be a little bit slower. But for those of you with a GPU, definitely select however many you have, likely one, and then click Save Preferences down here. Then in our device settings here, you can change it from CPU to GPU compute. But for those of you without a GPU, we'll just leave it on CPU. Perfect. Now that we have that hardware acceleration enabled, what we want to do next is change the amount of samples that we're using. Now, I've mentioned samples briefly before, but samples are basically, it's really hard to describe them without describing an entire path tracing engine. But this comes down to the baseline. The more samples there are, the less noisy your image will be, but also the longer it will take. So higher samples, lower noise, higher render time. Lower samples, more noise, lower render time. And right now in our viewport, you can see we're currently rendering with 32 samples, and it's pretty noise free. I mean, it's clearly noisy, but when it comes down to it, compared to whatever this is, it's pretty noise free. So I'm actually going to drop the rendering samples, the final render samples, down to 64, which will introduce more noise into our image, but don't worry, I know a few tricks to help get rid of that noise, which we'll be going over shortly here. So drop those rendering samples down to 64, and then we're going to tweak some light path settings. So basically, when Cycles renders, it actually physically simulates light bounces, right? It creates invisible rays of light or virtual rays of light that then bounce off our geometry just like they would in the real world. So in order to optimize this, we need to optimize the number of bounces that our light takes. Right now, we're taking a total potential of 12 bounces, and each of those bounces is a computation. So if we drop the total number of bounces down to 4, that means that at most all of our light rays are only going to take 4 bounces, which should help optimize things a little bit because 4 computations versus 12 computations is a pretty big difference. Additionally, let's uncheck these boxes down here by reflective and refractive caustics. If for some reason this isn't dropped down, it is just under the caustics tabs here. Caustics are basically the reflections and refractive focus points of light. So if you imagine taking a cup of water and setting it in the sun, you'll notice that it focuses light and makes some really cool patterns. Or perhaps you've been in a swimming pool and you see the waves creating that really cool pattern on the bottom of the pool. Those are caustics. Our scene doesn't have any, so there's no reason we should be wasting time computing them. So we'll go ahead and uncheck those, and we'll shrink down our light paths settings here. Additionally, we'll check this box that says motion blur. This basically means when we render, we'll be using motion blur, which if you're not familiar with motion blur, it basically just makes things easier to look at because things in the real world have motion blur, so we should have motion blur in our CG renders. Additionally, let's go ahead and open up this performance tab down here. And under the tiles, we have the option to change the tiles X and Y. And tiles are basically, when we actually render our image using the path tracing rendering engine, we'll see these little squares moving around on our scene. These are tiles, and we're basically setting how big they are. Now, on GPUs, these tiles should be relatively large. On CPUs, these tiles should be relatively small. So if you're on a CPU, set the X coordinate or the X size for our tile here to 30, and the Y size to 40. So on CPU, X should be 30, Y should be 40. But if you're using a GPU, we're gonna set this to 300 and 400. So CPU 3040, GPU 300, 400. All right, and I'm using a GPU, so I'm gonna leave that there, and I'm gonna shrink down our performance tab here. Next, I'm going to come up into our view layer settings right here, and I'm going to check this box that says denoising. And basically, remember when we dropped the samples down and created a noisier image? Denoising helps us get rid of that, right? When we render our image, it will run the image through an algorithm that helps get rid of some of that noise. Now, denoising can be a little bit risky to use, especially if you don't know what you're doing, because if you render at a really low sample count and try and denoise it, you're gonna get a really ugly render because the algorithm isn't that good at picking out noise. But if we do have a sufficient amount of regular face colors, I guess, or as long as we don't have too much noise, denoising comes out just fine. That's what I was trying to say there. All right, and with that, we have fully optimized our render. Let's go ahead and check this out. I'm actually gonna skip to a frame where we have our smoke here so we can see this. You can actually see what that material did now that we imported. Remember when we were in the Eevee rendering engine, this was all just glowing orange, but now we can see that that smoke as it's emitted is like a fire particle, and then it becomes smoke as it gets older, which is kind of cool. So let's go ahead and just really quickly render one of these frames. This will kind of give you a baseline of how long it might take to render this animation. So I'm going to select this random frame here. This is frame 163, and I'm just going to come up and click render and then render image. And you'll notice we see these orange squares moving around. These are tiles, right? We set the resolution for these, and they go around and they render our scene. We can see them, you know, some of them, you might have just seen a bunch of noise disappear there. See this noise? Oh, see that noise go away? That's denoising in action. And all like that, we've already rendered our scene. It took me 15 seconds to render this scene using two GTX 1070s. So it might take a little bit longer depending on your computer hardware. Actually, it probably will take longer because I have a pretty beefy system, but it all comes down to that computer hardware at this point once we've optimized our render. So go ahead and let yours finish rendering if it hasn't already, and then go ahead and just make sure that everything looks like it should, and mine definitely does. So I'm gonna go ahead and exit out of this render result, and I'm going to go ahead and set up the output now. So if I come into our output tab here, it looks like a little printer. I can change a few different settings to determine where our files actually get output to. The first one is the output directory, where our file is going to be saved to when we actually render. So right now it's saving to a random temporary folder. We don't want that. I'm gonna save it to my desktop because that's just an easy place for me to remember. So I'll save it to my desktop, and I'm going to give this a name. We're gonna call this Rocket. All right, just like that. Or actually, you know, even better, we'll call it Rocket Launch because that's more descriptive and better overall. And then we'll click Accept up here, which means that when we render this, it will render it to a file called Rocket Launch on our desktop. Additionally, let's change this file format from PNG to FFmpeg video. And this is pretty important because if you select PNG and you render this animation out, you're just gonna have a bunch of PNG images on your desktop, just like you're gonna have 250 image files. We don't want that. We wanna use a video file. We want an MP4 or something that we can play easily. So we'll select FFmpeg video. And then in the encoding options here, we're gonna change the container from Matroska to MPEG-4, which will give us the .mp4 extension, which will run on pretty much any operating system that you could possibly imagine. Then we'll leave the rest of the settings as they are here. And like that, we are completely and totally ready to render. So I always like to, before I render, go through, look at a few frames, make sure everything looks right. So far it does. Looks good here. Maybe we should render a scene really quick to make sure that this this smoke spreader actually disappears. So I'll render an image here. And we can see it doing its thing, working its way through the render. And we can see that it doesn't render the smoke spreader. Perfect, that's what we want. This is looking promising. I don't think there's gonna be anything we have to change here. Look at that. If we look up close, we can see there's very minimal, if any, noise thanks to denoising. All right, I'm gonna go ahead and exit out of this render. We'll jump to a different frame from a different angle. Still looks good. And here we see some launch things. Let me get something with some high velocity here. We'll get when our rocket's like finally leaving the stage, just like that. We'll render a frame here. Render image, or you can press F12, which is the hotkey for this. And you don't have to render this many things. Here you can see that motion blur in action, right? Because our rocket's launching upwards, it has motion blur on it in respect to the camera. You see our launch pad sits down here untouched. Man, this is looking good. I think with that, I'm confident enough to say that we, ladies and gentlemen, are ready to render. So I'm going to jump back to the very first frame. It doesn't really matter if you do this, I just like to. And I'm going to click File and Save. Always save before you do a render because rendering is when Blender tends to crash the most. That's just how it is. So always save before you render. It's a very good practice to get into. And when you're ready to render your animation, all you need to do is click Render and then select Render Animation. So I'm going to start mine now. Do note that rendering your animation will take a good amount of time. Even on my system, this will probably take about an hour to render. So actually, we can do the math to figure it out. I'm gonna wait for this frame to finish rendering here. All right, so you can see that this frame rendered in 14 seconds, and now we're actually on to frame 2, right? Because we're rendering the animation as we go here. So frame 2, the last frame rendered in 14 seconds. Let's see how long this one takes to render. I'm guessing it's going to be 14 seconds as well. Yeah, just 14.7 seconds. So we're getting about 14, 15 seconds. So let me open up actually a calculator here, and we can actually calculate the amount of time it will take, or at least an approximate guess as to how long it'll take to render this whole thing. So it took about 14 seconds to render that one frame, right? And we have 250 frames of animation to render. So let's multiply it by 250. Whoa, hang on, I'm dumb. Sorry, 14 times 250. All right, and if we click equals, we'll see that it takes about 3,500 seconds. And if we divide this by 60, because there are 60 seconds in a minute, we get 58.3 minutes. So just about an hour on the dot for me to render out this entire scene. So do make sure that if you are rendering, your system's probably going to become quite laggy, quite slow, quite unresponsive, especially if you're rendering on a CPU because everything else runs on your CPU. So do keep that in mind. I always like to start renders before I go to bed at night because then I can just let it run as I sleep and then I wake up in the morning to a nice, clean, and finished render with nothing to worry about. But in this case, I'm just going to let this finish. I'm going to go make myself some dinner because it's dinner time, and I'm going to end the video here and we'll resume with our finished render in the next video.